Our second objective domain is describing the fundamental principles of machine learning on Azure. Within this objective domain, we're going to identify common machine learning types. We'll look at core machine learning concepts, as well as identifying core tasks in creating a machine learning solution. And then finally, describing the capabilities of a no-code machine learning inside of Azure Machine Learning. Let's go ahead and explore our second objective domain of the day, which is a bigger portion of the exam, where you can expect about 30 to 35% of your overall exam coming from the second objective domain. And in this section, we're going to be covering machine learning. And really, machine learning is the foundation for all of the different artificial intelligence solutions that we'll be taking a look at today. We will explore supervised versus unsupervised classification, regression, and even clustering. So let's go ahead and get started with it. So why don't we go ahead and get started with identifying the common machine learning types. You will definitely see a lot of different questions on this particular topic. So machine learning is a technique that uses mathematics and statistics to create a model that can predict unknown values. Now, at this AI 900 level, you're not going to necessarily need to do any type of math, so again, don't worry about that. But what you need to understand is that machines learn from data. In today's world, we create huge volumes of data as we go about our everyday lives. And what we have are data scientists who can take in all of that data to train machine learning models that can make predictions and inferences based on the relationships that they find in the data. The common machine learning techniques are regression, classification, and clustering. We're going to explore each of these techniques in just a few slides. So first, let's take a look at regression. Regression is a form of machine learning that's used to predict a numeric value based on an item's feature. So what we have here is regression is a form of supervised machine learning. And what this means, it relies on having some type of data with a known label value. And we can fit that into a model. Now, from there, it can then be applied to new data that we don't have those label values. Now, to train a model using data, it includes both the features and the known values for the label. So the model learns to fit the feature combinations to the label. Then after training has been completed, you can now use that newly trained model to predict labels for new items for which that label is unknown. Features are nothing more than attributes. And on the same side, labels are nothing more than a target variable. So let's actually talk about an example for a second. Let's say, for example, we have a car sales company. They may be using characteristics of a car, and this could be anything. This could be the engine size, the number of seats, mileage, safety features, anything. And they're using that to predict its likely selling price. In this case, the characteristics of the car are the features, and the selling price is the label. So that is an example of that regression. Why don't we actually explore another type of supervised machine learning, and that's classification. Now, classification is a form of machine learning that's used to predict which category or class an item belongs to. So just like with regression, we're going to start with some data that includes some features and known labels. All right. So suppose we are, frolicking in the field, and we have our friend is a botanist, and we're helping them collect samples of different flowers. Now, each flower is going to have different features with those. All right, they are going to have different things like petals, the stems, the number, the color, all of those different things. Well, our friend, the botanist, who went to school for this, they're providing a label for the flower and that species name. Well, what we have is all of that sample data that we've collected, because we have the name, we have the label, we have all of those details, all that data on the flower. That sample data is then processed using an algorithm that's working to find a relationship between the features and the label. So the result of this algorithm is that we have it where the model has been trained in such a way that it can actually find a relationship between that features and labels. And you can then use it to predict the species of a flower just based off of its features. What this is an example of a classification technique. So we've looked at 2 supervised models. Let's actually look at an unsupervised technique. Finally, the last one is going to be that unsupervised, which is clustering. Now, clustering is where we are trying to predict what category or class an item belongs to. All right, so again, this is unsupervised, where we are separating items into clusters based purely on their characteristics or feature. And what we have here, because it's unsupervised, we don't have a known cluster value or label from which to train the model. So an example of this is where a researcher is taking measurements of penguins and grouping them based on similarities to their proportions, then using that data to train a machine learning model. So those are going to be the 3 different types of machine learning that you will need to know for your exam. And again, you can expect a lot of questions on that. So why don't we go ahead and move on to our second area of the objective domain, is describing core machine learning concepts. Now, what we've learned earlier is that machine learning works by identifying relationships between data values that describe characteristics of something, known as its features, and then the value we want to predict. And this is what we call the label. And then what we do is we encapsulate these relationships in a model through the training process. So let's use another example. Let's say we have a university and we have a professor who's collecting data from their data science students. So let's say that they're collecting data on the number of lectures they attended or the hours they spent studying. And then finally, they're looking at the grade that they achieved at the end of the term. So what the professor could do is then take a sample of the data and then analyze it to determine if there's a relationship between the amount of studying that a student did and the final grade that they received. They could then prepare the data to train a machine learning model that's actually going to predict a student's grades based on their study habits. And I wish I had that model when I was in college. But what we need to talk about is when we talk about training and validation, let's actually go into a little bit more detail with that. So what we have is there's a couple different options when you're setting up your training or validation split sets for cross-validation and your automated machine learning experiments. So what you're going to do is you're either going to start with a single data file and split it into training and validation sets, or you can provide a completely separate data file for validation. Really, machine learning algorithms are going to be used for model training. So why don't we go ahead and dig a little bit more into what that means and the different algorithms that are used to train and validate your machine learning model. So the Azure Machine Learning Library has a huge amount of algorithms, from classification recommendation systems, clustering, anomaly detection, regression, and all sorts of different ones. Now, each of these is designed to address a different type of machine learning problem. Now, don't worry about trying to capture all of this. This is all going to be in your study guide, but just know that this is a great piece of documentation, and it's going to explain each of the different algorithms that you can use for testing and training your model. All right, so we're moving on to our third area. Let's go ahead and explore identifying core tasks in creating a machine learning solution. Now, with a machine learning solution, you need to take in data. And that's what we get when we start talking about data ingestion. What this is a process that you have unstructured data, and it can be taken from one or a number of different sources. And then it's prepared for training a machine learning model. So when we talk about data ingestion options, we have a couple available within the machine learning environment. The first one is going to be the Azure Data Factory pipeline. This is built specifically to extract, load, and transform data. Or you can use the machine learning Python SDK. This provides a custom code solution for data ingestion tasks, or you can use a combination of both. Really, data ingestion is a very time-intensive thing, and it can be a huge burden, especially if you're doing it manually. So if you have large amounts of data from multiple sources, you may want to consider automating it. What this does is this is going to free up resources and ensures that your models use the most recent and applicable data. All right. One thing I do want to make sure that you understand, and this is a high-level feature engineering where we are taking raw data and selection. So with feature engineering, this is applied first to the additional features. And then feature selection is done to eliminate irrelevant or redundant or really highly correlated features. So what we want here, the goal here, is to identify a set of independent variables that are collectively a strong predictor of variable that we're trying to predict. Feature engineering is really just the process of creating new features from raw data to increase the predictive power of that learning algorithm that you chose. So engineered features should capture additional information that's not really apparent in the original feature set. And what we have is this is overall the process of selecting the key subset of a feature to reduce the dimensionality of the training program. All right. So the automated machine learning capability in Azure Machine Learning is going to support supervised machine learning models. Why don't we look a little bit more into that? So the machine learning that is typically used to establish a good baseline for a model. So when you have that, you're going to usually follow up with a more detailed or exhaustive machine learning process. This link that I'm actually showing you in your on the screen right now, you're going to find this in the study guide. All right, so don't worry about trying to write everything down. This is documentation that's on Learn that's really good about describing the model for training and evaluation. Last area for Objective 2, why don't we go ahead and explore the capabilities of no-code machine learning inside Azure Machine Learning. All right, so Azure Machine Learning is a cloud-based platform for machine learning. So when you're trying to train or deploy an effective machine learning model, oh gosh, there's a lot of work to be done. Azure Machine Learning is a cloud-based service that's going to help simplify some of those tasks, and it helps reduce the time it takes to prepare data, to train the model, and ultimately deploy that predictive service. Now, to use the machine learning, you're going to need an Azure subscription where you're creating a workspace with resources such as compute and data. You can actually use this data to run experiments on those compute resources. And often, those experiments are used to train the models. And when the models are ready, you can publish them as services. So you may be wondering, how do you train a machine learning model for regression or classification? Let's try to understand it a little bit better. So with machine learning inside of Azure, what it does is it allows non-experts, like myself, I'm not a data scientist, to quickly create effective machine learning models from data. So this is actually one of the easiest ways to train a machine learning model for regression or classification. There's a visual interface for automated machine learning in the Azure Machine Learning Studio, and you can access this through the web portal. All you need to do is supply the training data and select the required model type, and then you know what? Azure Machine Learning's taking over and doing the rest for you. Now, before we actually explore the Azure Machine Learning Designer, I want to make sure that you know that both Automated Machine Learning and Machine Learning Designer are both very powerful and pretty popular when it comes to creating machine learning workflows. I would probably say you can expect at least one, if not two questions on the exam when it comes to these topics. So, in the machine learning, it's a multi step workflow to help prepare the data. All right. It can train models and perform model management tasks that are called pipelines. The designer tool in Azure Machine Learning Studio enables you to run pipelines using drag and drop visual interface, connect the modules that define the steps and the data flow to the pipeline, and it's really a great tool. I'm going to include this documentation as well as the concept designer, so that way you can learn a little bit more of that. But with that being said, why don't we actually take a look at the Azure Machine Learning Designer? All right, I am logged into my Azure portal. Now, there are no lab components on the AI 900 exam, but I do want to at least have you be semi-familiar when it comes to the Machine Learning Studio. So, in order to create a Machine Learning Studio environment, is that you can go here to the portal menu, select All Services, and then you can actually scroll down to where it says AI Machine Learning. All right. I'm going to go ahead and select Machine Learning here to create my Machine Learning Studio. And then I'm going to select Add. Now, when you are creating any resource inside of the Azure portal, you're going to need a subscription. So I'll be using the one I have here. And you do need to have a resource group. All right, a resource group is just that logical container for organizing your resources. I'm going to select my AI 900, and now we need to name it. It does need to have a globally unique name. So why don't we name this AI 900 Exam Prep? All right, it is a globally unique name, so I'm going to name my workspace that. And then I need to select a region. Now, a couple cost-saving tips for you. If you are going to deploy a Machine Learning Studio, try to choose a lower cost region or one that's close to you to help reduce latency. I'm going to go ahead and use East US. And you can see from here, it is going to automatically create a storage account for me, a key vault, application insights, and a container registry. I'm not going to create a new one for the container registry, but I can have one here. But it will automatically create these for me. I'm not going to go into that right now of the details of what those are used for, but you can check out the documentation to learn a little bit more. Other than that, I do not need to go through any of the other settings in order to do that setup. It's going to run my validation, and then I'm going to select Create. Now what that's going to do is it's going to initialize that deployment, and not only is it creating my machine learning workspace, but it's also creating that storage group, that key vault, and all those other resources. Now I've gone ahead and already created a machine learning environment, and we can find that in my AI 900 resource group. And so we're going to go ahead and open up my Machine Learning Studio. You'll select your Machine Learning Studio from your resource group, and then on the main page on Overview, you'll select Launch Studio. After your workspace loads, you'll be automatically redirected to the Machine Learning Studio, where then you can manage your different data environments, your different data sets, your experiments, as well as your compute. So you do need compute in order to set up your testing. So the first thing that we need is we need to create a compute instance to process and run all of our machine learning efforts. So I'm going to go ahead and select Create. And I'm going to use a CPU. I'm going to use the standard D11 V2. And then it's going to ask me for a compute name. I like to use my username as my naming convention, but you can use whatever works best for you. I'm going to select Create, and that is then going to enable the compute instance to run my machine learning experiments. Then I'm going to create a compute cluster. This is what's going to be used for our training and validation for any data sets. So in order to do that, I'm going to select Create. And I'm going to use the D11 V2 again. I'm going to have a dedicated machine. That way I'm not sharing that workload with anyone else. CPU. And then I need to name my compute. All right, so I'm going to have my minimum number of nodes. Again, I would not leave this running if you were not using it or doing any type of experiments. So I'm going to name this using my naming convention. All right. Oh, too long. Let's try this. There we go. Not too long. All right. So I'm going to add 2 nodes for testing. And then for this, for the seconds before scaling down, let's go ahead and just change that. I think I'm going to leave it as 120. What this does, and again, if you're not sure what anything does, you can always hover over. What happens is if I'm not using these nodes, it will automatically scale it down to help avoid additional charges. But what I'm going to do is I'm going to go ahead and select create. So once my compute and my compute clusters are loaded, I'm good to then load in my data sets. And again, it's very simple here. So instead of having to try to process this on my own, I can actually upload or create my data sets here. So once I've uploaded a data set, I can actually then come in and run an experiment or create a pipeline. So again, the Azure Machine Learning Studio makes it really easy to set up, test, train, and deploy your machine learning services. That brings us to the end of Objective Domain 2. So why don't we go ahead and check your knowledge with some practice questions. Again, just keep in mind that there are going to be a number of different question types on the exam. This is an example of something that you may see. So let's go ahead and read that together. A bank wants to use a historic loan repayment record to categorize loan applications as low risk or high risk based on characteristics like the loan amount, the income of the borrower, and the loan period. What kind of machine learning model should the dealership use for the automated machine learning to create? You're going to choose one of these 3 options. Is it classification, regression, or time series forecasting? I'm going to give you 30 seconds to answer. The correct answer is classification. Remember, if you're wanting to predict a category or a class, you're going to use a classification model. Question 2. You use an Azure Machine Learning Designer to create a training pipeline for a classification model. What must you do before deploying a model as a service? Please choose from one of these 3 options. 1. Create an inference pipeline from the training pipeline. 2. Add an evaluate model to the training pipeline. Or 3. Clone the training pipeline with a different name. I'll give you 30 seconds to answer. The correct answer is to create an inference pipeline from the training pipeline. You need to do this in order to deploy it as a service. Let's go ahead and do a quick recap of what we've covered in Objective Domain 2. We've reviewed quite a few different items. We've looked at machine learning as an overview. We looked at examples of regression, classification, and clustering. We reviewed some of the machine learning core concepts as well as the tasks in creating a machine learning solution. And then finally, we did a quick tour of the Machine Learning Studio, which is an automated machine learning designer inside of Azure.